I'm going to bring Ary on, and I would introduce him, but I feel like he's just so well known at this point in the community. But he is the creator of Crystal, and he'll be talking about Crystal on demand. So Ary, take it away.
Hello, can you hear me?
We can hear you.
Great. I'll share my screen. So what is Crystal on demand? Sorry about that. So you might be thinking that this talk is going to be about me showing what's the current demand for Crystal and what we want it to look in the future. But no, much less with this kind of graphics. So what's Crystal on demand? Crystal on demand is asking for Crystal and getting it right away. And it's also Crystal flowing out of your fingers, reaching the computer and getting an answer back. But enough with the mystery. It's time for a demo. So you might be guessing what this does based on the branch name, but essentially the idea is that to have a tool like this, it's called Crystal Eye, that you run it and you can start typing things like this. You can do additions. And at this point, you might be thinking, this is just a wrapper around IRB, which is the equivalent for Ruby. So let's try some crystalisms. You can see that this is Crystal. We can also try this, which is unique to Crystal. Let's try a few more things. For example, a range that I can convert to an array, or remember this range. What if we cycle it and map each element to the power of 2, take the first 30 and turn that into an array. I still have time to show other things. I think so, just 4 minutes past. Let's see this. You can see it's working just a bit more. I want to play a bit more with this. I'll require JSON. Parse array. Just a second. Nice. The array. What about the permutations? It all works in this way. So this is Crystal on demand. And why make a REPL now? What you saw is a REPL. You might be familiar with it. It's read, eval, print loop. So why make it now? Why not before? Or why not after? And the real answer to that question is that I was invited today to give a talk for this important conference, and I didn't know what to talk about. So I thought that, and given the importance of this conference, the 1.0 release, I wanted to talk about something that would be great, that would blow your mind, that you would say, "Whoa, this is great. I'm so happy to have this tool." And I had the idea for REPL for Crystal for a long time now. During the early versions of Crystal, I started working on REPL, but at that time, it was too much, like working on designing and implementing the language. And on top of that, a REPL was too much. So I didn't continue working on that. But now that the language is stable, now that we reached a 1.0, I wanted to give it another try. And as I was building this REPL, which I started about 2 months ago, I realized how much it can enhance the language, the developer experience or developer happiness. So we'll go over the nice things about this, but I also want to talk about like what are the challenges or pros and cons of a REPL for Crystal. So let's start with the cons. One is that we have to make sure the REPL works the same way as the real Crystal. It's a different implementation of, like the semantic pass is the same, but after that, it's a bit different. It's compiling the code to bytecode and having a VM run on top of that. So imagine you use a REPL, you try something out, you copy that to a file and run it, and it runs differently, and that goes to production, that would be a problem. But and there's also the thing that it's more work for us to have these two implementations. But I think that with time we can make it happen. If you find something that doesn't work, you report it as a regular bug, we fix it, and with specs and regression specs, we can make it work the same way as the real crystal. And you saw it's working already like that. And it's more work to do, but it's only a burden, let's say, for just the compiler developers. And I say a burden, it's actually super fun to work on this. And the benefit is for the entire community and even the compiler developers. There's another cons, which is that it's slower than the real crystal because it's interpreted. In fact, at this point, it's slower than Ruby. But I think it's fine because this is not meant to go to production like it's a tool. You won't deploy this to production and people will see it's slow. And I think it can be enhanced over time. So I didn't optimize it a lot yet. And I'm sure it can be optimized a lot more given the typed nature of Crystal. Now let's see the good things of this. So I think one is being able to explore the language like this, like you download a shard and you open the REPL and start playing with it to explore what you can do. It's great. Like we have this power in Ruby and it's awesome. And another one is that if Crystal is too fast for you, you can use this new tool Crystal I to slow down and relax a bit. And I'll show you what I mean with this exactly. So if we go back to the console, there's this sample that we have, Mandelbrot, that I can compile. And then if I run it, the first time it's a bit slower in Mac, but the next time you can see it's fast. It's about, I don't know, 67 milliseconds. And if I run it with Crystal I, this is something new that I didn't tell you. You can also run existing programs like this. Instead of like running it like this and starting to type Crystal, you can run it in interpreted mode. And you can see that it takes half a second, which is slower than 16 milliseconds. So it's slower. So if you need to calm down, but in reality, if you're working on a script or something that has a fire and forget nature, for example, a spec, if you time how long it takes to do the semantic analysis, generate LLVM code, convert that to bit code, then to object files, link all of them and execute that, it takes about 1.5 seconds. But if you run it in interpreted mode, as we saw, it takes half a second. So it's actually, in some cases, it can actually be faster, or the development cycle can be faster. So I was just kidding when saying this is slower. It's slower, but it depends on the use case or how you use it. There are other samples that I'd like to show you. There's this example, which is using the Crystal formatter, which is done in Crystal. It takes a source code that's unformatted. You can see there are superfluous white space or double white space here. And it formats it and outputs the result. And this is using already a lot of Crystal code, like it's using the lexer, the parser, outputting things, arrays, hashes, you name it. You can see we can run it. It's relatively fast and the program gets nicely formatted. There's another nice sample that I want to show you. That's a text ray tracer that we have in this directory, where it outputs 3 spheres in text mode. I don't know what happened. Sorry about that. it was working the other day. Let me try something. Let me drop here, and I'll run the program again. Okay, and now we can see this is fine. This is fine. Let's go over the next line. Let's output this. Is this the problem? No. Next. What's this trying something out? I wonder if it's that. It seems to be printing random characters. It's true. You know what? Just a second. What? Let's set it to false. Now let's continue running it. Okay, now we're talking that this is the expected output. But I just revealed to you what I think is the most useful feature of this interpreted mode, which is being able to debug things when things go wrong. And Crystal, before this tool, already supports a form of debugging through LLDB or GDB. But those tools don't understand Crystal as well as this tool. Like you saw me like evaluating Crystal expressions like this or puts, and it just works. And the design of this is similar. You might have noticed if you use it to pry from Ruby, where you do binding pry, you have next or step or finish to get out of the call frame. So this is the actual power of interpreted mode. And I think this is huge, and it will be super helpful to develop Crystal. And you saw me also modifying memory or local variables, and after that, continuing the program. It just works. So I was kidding with this. In reality, well, it's slower, but it can be potentially faster. It can bring potentially faster development cycles. And you also get a built-in debugger that truly understands the language. And from like having this interpreter could enable a lot of things. For example, what about hot code reloading? It's super hard to do, but I think with this interpreter, it's more approachable to do because things are in memory. It's not like we compile the code to an executable that's frozen and it's hard to change. We could also have code coverage. You saw me stepping through the code, so the interpreter knows which lines are executed. So we could gather that information and generate a code coverage output. We could also support auto-completion in the REPL to be able to more easily explore the language or a library, even maybe provide inline documentation there. So you saw a lot of things working in this mode. It's not a prototype. It does a lot of things already, but there are some things that are missing. Raising and rescuing exceptions, it's not done. It's not exceptionally hard to do. Closures, which is when you use a local variable inside of a captured block. And bindings to C functions outside of libc. But this don't work only because I didn't have time to do them already. They are totally doable. I just wanted to focus on the hard things first. And you will see that something is missing from this list. So it's done. So I want to show you something else that's already working. We have this program that spawns 3 fibers, and each of them loop 10 times and print something to the screen, but they have different sleep times, and then the main fiber waits for input. That's already working in interpreted mode. And as usual, I can drop a debugger here. start debugging. You see that there was already some output. I can inspect continue. Other fibers do some work, and we go back to this fiber, and so on. And here you can step as much as you want. So fibers and concurrency, at least in single thread mode, already work. And so what's next? How does this continue? So my idea is to send a PR with this new tool to the main repository. First, making sure that it's properly commented and that others understand it. It's relatively simple, I think. And the tool can be considered experimental, like we can merge it right away. It's already useful or usable. It's not complete, but there's no risk in it not working correctly or not being complete, because the code that you produce there won't go to production. It won't affect an end user. And together we can complete and improve the tool after that point together. And I'm sure a lot of you know about techniques to optimize or improve the user experience here. So thank you so much for being here, for being an awesome community. Questions?
Thank you. Background went away. Yeah, thank you so much. All right, this is, I mean, there have been so many praises coming from the chat. I think when you first switched over to demo mode and showed that it was working, I think people really, really enjoyed that. There's a lot of thanks in there. I'll start off with Henry's somewhat flattering question of, is it really as fast as it seems to be in the demo?
Is that a question? I think, well, it's as I said, it's slower than Ruby, but it's like the speed is okay. It's done, talking a bit more technically, it produces bytecode for a stack-based virtual machine, which is similar to what Ruby does. I actually took a lot of inspiration, again, from Ruby and read a lot of things about interpreters. But it's not super optimized yet, but at least it's done in a way that will enable optimizing it further and further. But I think it's for the use case of using it like a debugger or a REPL, the speed is fine.
Awesome. Is it Marcus asks, can this be used as an official language server?
It's a good idea. Yes, I think it can't be used right now, but it could be like similar as hot code reloading. It could enable that, like having a program that's up and running and knows about the structure of the program, so it allows you to enable auto-completion for an editor, not inside the REPL or outside of the REPL. And as you change things, here's the challenge: as you change things, we have to update the type information and what we have in memory. That's the challenge, but I think it's doable. It's hard, but doable.
Okay, I'm going to skip around here a little bit, but I also want to remind people, if you're in the chat and you have questions for Ary, this is a great chance to get them in. There's one from Brendan that says, what code works differently in the REPL than it works in regular Crystal? It seems like you covered some things that are not working, but I think this is specifically about code that would work differently in one versus the other.
It's a good question. I think all of the code will work the same way, unless we have bugs. But the way it's done, it keeps things in memory, or it produces things in memory that match the real crystal. So for example, if you go low level and you have a pointer, which is a crystal type, and you locate memory for, I don't know, 10 in 32, that in real crystal would occupy 40 40 bytes, I think. And the REPL does the same thing. Behind the hood, it allocates 40 bytes of memory. And maybe the difference, so fibers work a bit different. So when you do a context switch, this is technical, but it does a context switch on the interpreter. So some things aren't exactly the same, but for a user using the REPL or interpreted mode, the output should be the same. I was playing a bit on this with Juan, and he said like this is a different backend for the language. So we have LLVM, we could have code that generates C code. This is just generating bytecode, but it should work the same way.
Okay. There are a few questions here about macros. I'm sorry. Oh yeah, there are a few questions here about macros. I guess just what about macros? How do they work? All that, you know, in general, is there any difference between core crystal and interpreted, or the interpreted crystal and macros, and how does that look?
Again, a great question. So the nice thing about macros is that in the semantic pass, macros are expanded to crystal code. So, and for the interpreter, I didn't have to worry about macros because macros disappear from the language, or from, at that point, I don't have to worry about macros. They were already expanded, so they work. They work exactly the same as in crystal.
Awesome. That's pretty cool to know. I think it's been a pretty cool part of the language, and it's awesome to know that something like this can just adopt a lot of the features of macros without a lot of work. There is a fair amount of questions about this being merged. I think you covered that it's ready, and that, you know, there could be a PR and stuff, but I think there's a question about when people can use it in mainline. So 1.0, 1.1, 1.2. There's a few more in here. I guess what's your hopes, or is there any talk of plans of when it will be merged, or put into PR?
Yeah, I think ideally as soon as possible. I'm not sure about 1.1 because it's already like in freeze mode. Mm-hmm. And I'd also like to take some time to review the code, and for others to review the code and to clean up things before merging that. So maybe for 1.2, so 3 months away.
Okay. Kirk has a question here, and I think he's doing an interesting talk later about dynamic crystals. So I'm sure he's looking ahead here, but can the interpreter be accessed from compiled code?
From compiled code. I think you could do that. You have to require the interpreter. The interpreter is built 100% in Crystal. So you could require the interpreter and interpret Crystal. I think the challenge there is interacting with existing variables or things that you have in memory and pass that to the interpreter. But given that the memory layout is more or less the same, it could work. I'm not sure. But at least as running it like a small scripting language, let's say Lua or something like that.
Yeah, I'm super interested what his use case is for. I'm hoping that he'll post more later. Maybe his talk will kind of help us see what he's trying to do. Postmodern has a great question, which this will be very interesting for Crystal as a language itself. Will Crystal I include some kind of documentation lookup command or tab completion? I think that kind of follows the language server question, but will it have those features, and are they possible?
I think that they're totally possible. Like I actually started playing with auto-completion before the talk. Like I wanted to prepare the talk, but it was so fun to keep adding things to the interpreter and see them working. But at one point I said, okay, I'm going to stop and focus on the presentation. But I started playing with auto-completion. That's totally possible. And also having like a way to look up documentation for types is totally possible, yes.
Awesome. This is a really great question. Christian asks, so you're using the compiler specs to validate the interpreter. I'm not exactly sure how that would work, but if you are using compiler specs to validate the interpreter, what percentage of the specs are passing?
It's a good question. The thing is that specs don't currently work because they use closures a lot, and that's not implemented. But I was thinking, so I don't know what percentage already works, but my idea was that once it's all of the features are working, we could run the compiler specs, test the language in interpreted mode to see like if they work the same. And that's actually could be a good way to make sure that things keep working the same way.
Mm-hmm. Kevin has a few questions in here and they all seem to revolve around one kind of topic. So I'm just going to kind of put them together, which is, will this REPL affect the current standing of the playground? Will they coexist? Will it be replaced? I guess this is a question of the future plans of the playground and the interpreter.
I thought about that too. I was wondering like what happens with the playground. And I think there are two like different tools for different purposes. Like in the playground, you can write a lot of code and see the output of each line. But I was thinking that the playground works right now by transforming the code that you have to change statements to print something or send something over a WebSocket. And we could change that to instead use interpreted mode to produce these outputs. So Crystal Playground will still be there and it will work faster and better, I think, if we decide to use interpreted mode for it. But I think the two can coexist.
Awesome. And if we have time, we might get into a few more, but I think Vlad has a great closing question, which is, how close is Crystal I already to the REPL of other dynamic languages like Ruby? And how much work do you think it will be to bring the full REPL support? So I think there's a few things in here, but how close or how similar is this REPL to dynamic languages? And I would kind of put in there like, what's the difference between dynamic language REPLs and Crystal's REPL?
So the main difference, I would say, with Ruby, I actually started implementing it more similar to Ruby, but then I changed it, is that Crystal is typed. And so in a dynamic language, all values usually have a tag that says what type they are. But in Crystal, if you have an integer and a variable that holds an integer that doesn't have a tag, it's an integer. And I mentioned this because the REPL already works, but if you define a type, let's say a class foo with one instance variable, and instantiate that and store it somewhere, and then you reopen the class and add a new instance variable, the REPL will have to search all of the foo instances there in memory and change them so that they also have space for this new instance variable. So it's pretty challenging, and that's currently not working. But if you have types predefined, that already works. And if you debug programs, it's unlikely that you will want to create new types or define new types. So I think that's the main difference, but it's a current difference. Like in the future, it might work the same way as in Ruby.
Okay. Thank you so much, Ary, for joining us. We are going to be going on to the future talks, but thank you so much. And there were plenty of questions after, so hopefully some people have some questions for you in the Discord.
In Discord.
Awesome.